5 is complex zeros and the fundamental theorem of algebra. First of all, as someone in my morning class pointed out, the I's are back. My comment is the I's never really left. We just haven't used them in a while, but the I's are here. A lot of several of the pieces that we're working with today, when we talk about some of these theorems, are related to stuff we've done last year in Algebra 2. Okay. In fact, some of the same stuff I'm teaching at varying levels in Algebra 2 right now. So, okay, a couple of things here. First of all, the fundamental theorem of algebra. A polynomial function of degree n has n complex zeros. So that would be of the real and non-real variety. Some of these zeros may have a multiplicity greater than 1. In other words, they might be repeated. We've talked about, this relates back to, we've talked about, for instance, if it's an x squared equation, how many answers are you going to expect to have? You're going to expect to have 2, right? If it's an x to the third equation, x cubed equation, you usually expect to see 3 answers, so on and so forth. That's what that's saying. The key here is saying that if it's degree n, it does have n zeros, but complex, when we start talking about complex, refers to real and non-real. So when we talk about complex zeros, that's the form a plus bi, which a plus bi could be totally real, or it could have an imaginary part. So, but n degree does have n zeros. Whether you can see them all, whether they're all real or not, it's a whole different story. Okay. We also have the linear factorization theorem that goes along with this. Given the function of degree n, then f of x has precisely n leading factors. Okay, so degree n has n leading factors, which makes sense because if there's n zeros, each zero has a factor. So then there are n factors. And don't let me forget, this will apply when we get to the back page tomorrow or Monday, whichever I do those notes. A is the leading coefficient. Okay. And then the other one, complex conjugate zeros theorem. This one we definitely would have used last year. Given a function f of x with real coefficients, if a plus bi is a zero, then so is its conjugate. Okay, remember conjugate is you're changing the middle sign between the two terms, basically changing the sign in front of the imaginary portion. And so if a plus bi is a zero, then so is its conjugate. And that's where I've kind of referenced that imaginary zeros always occur in pairs. Same thing. This doesn't reference it, but irrational. The square root answers always occur in pairs as well. Okay. Let's look at example 1. They ask us to do 3 things. They ask us to write example 1, write the polynomial function in standard form. We're going to identify the zeros of the function, and then we're going to identify the x-intercepts of the graph. Okay. Thoughts on standard form? Okay, FOIL. In other words, right now it's in factored form, yes? We're talking standard form. It's all multiplied out, and when you write it in standard form, you're going from highest power to lowest power. Okay, so we're going to start there. We're going to start by foiling this out. And so if we FOIL, first x times x is x squared. X times plus 2i. I'm going to write that as 2ix. Insides, negative 2i times x. Negative 2ix. And then negative 2i times positive 2i is what? Minus 4i squared. Okay. What do you notice as we go to clean this up? Okay. These were conjugates, weren't they? X minus 2ix plus 2i. Your middle terms cancel. 2ix's cancel. What about 4i squared? What do we need to remember here?
Doesn't it become 4?
It does become 4. Okay, so small review. First of all, what is I equal to? Just plain old I. I is the square root of negative 1. If I is the square root of negative 1, what is I squared equal to? Negative 1, because when you square square root, you get the negative 1 there. Does this sound familiar? I know we always need that reminder. So when we get over here, we have x squared and minus 4i squared. Minus 4 times negative 1 becomes plus 4. So right here, f of x equals x squared plus 4. This is our standard form. Okay, are we good on standard form? I was just multiplying it out, yes? Okay, next question, zeros. Thoughts on how we find the zeros?
Just set that equal to 0.
Okay, so one option would be setting this equation equal to 0. Now, in the process, well, I guess this one we have a couple of different options. But one of the options is usually to factor, right? So besides saying this equal to 0, what else could I do? Could we go back and set our original factors equal to 0? And could you set x squared plus 4 equal to 0 and solve? You can. You'd get there just fine. But when we get to b and we've multiplied it out for standard form, I don't want to go back. Okay, I don't want to have to resolve that. So I'm going to set each factor equal to 0. So I'm going to set x minus 2i equal to 0 and x plus 2i equal to 0. What do we get for our answers here? X equals what? 2i and negative 2i. And these are my zeros. Okay? When we talk about zeros, they are your solutions to the equation. Okay? The final and third piece you're asked for are your x-intercepts. Thoughts on x-intercepts? What are x-intercepts usually the same as? Your zeros, yes? Okay, now, interesting enough, Jack has his calculator in hand back there. Okay. Just think about x squared plus 4. We don't even necessarily need a calculator for x squared plus 4. And you're fine. I'm not saying it's a bad thing. Okay. You're trying to graphically look at the x-intercepts, right? But what do you know about the graph x squared plus 4, guys? It's a parabola moved up 4. Is a parabola moved up 4 going to have x-intercepts?
No.
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 But I had 2 zeros. If I have 2 zeros, shouldn't I have 2 x-intercepts? What's the key about these zeros? They're imaginary. So imaginary zeros, are we going to see them on our graph? Are they going to create x-intercepts? No. Now, if we had real zeros, would those overlap as x-intercepts? Yes. Real zeros are going to be the same as x-intercepts. Imaginary zeros don't fit that mold. So in this case, since we had 2 imaginary zeros, what do we have in the way of x-intercepts? We have no x-intercepts. And I'm going to put a little note here. Why do we have no x-intercepts? Because my zeros are imaginary. Okay? So yes, I often will generalize and say that x-intercepts, zeros, solutions are all the same. And they are to an extent. Except x-intercepts, they have to physically be there, and imaginary zeros cannot be. Okay, questions there? Okay, let's look at B then. B asks us to do standard form. Now, as you look at this problem, notice f of x equals x minus 3 times x minus 3 times x minus square root of 2 times I and x plus square root of 2 times I. Note that 3 has a multiplicity of 2. Remember multiplicity? Multiplicity is the power on a factor, right? Could this be rewritten as x minus 3 squared? It could be. So it has a multiplicity of 2. It also means that it's a repeated factor, or it's a repeated 0. So we're not going to see we're going to see 1 less 0, I guess we could say. Okay, standard form. What are we going to need to do? We're going to FOIL it out. Now, best suggestion to FOILing it out. Do this in pairs, yes? I cannot stress the importance enough. Anytime you have conjugate pairs or imaginary pairs, you need to multiply those conjugates together first. Don't try and do a square root of 2i and a 3. It's going to become a pain. It's going to become nasty. Okay? So, I would suggest x minus 3 times x minus 3. What are we going to get? X times x is x squared. What about our outsides and insides? Outsides are minus 3x. Insides are minus 3x. Minus 3x and minus 3x is going to be minus 6x. Minus 3 times minus 3 is going to be plus 9. Got to have you guys helping me out here. I've got way too many people trying to sleep. I need us to sit up. I need us doing the notes. I need help. We're going to be doing notes because we're going to take an extra day to do notes the way we're going. What about these last two? X times x is x squared. Can we shortcut this? What about our outsides and insides? Yeah. Yeah, we're going to have a plus square root of 2 times I times x and a negative square root of 2 times I times x. Conjugates, those outsides and insides cancel, yes? So then go to your last. What is negative square root of 2i times square root of 2i? Well, negative times positive is a negative. What's square root of 2 times square root of 2? Square root of 4, which can then turn around and become 2. What's I times I? I squared. Negative 2i squared can turn around and become positive 2, because negative 2i squared is going to be negative 2 times negative 1, or a positive 2. So then this can just become x squared plus 2. Good? Now we're not done, are we? We need to FOIL, distribute again. Okay? It's a personal choice of how you do this. Do you guys care which order we go in, or? I tend to take my 2 here and multiply them to the 3. So like I'm going to take this x squared from the back and multiply it times each of the first 3. So x squared times x squared is x to the 4th. X squared times minus 6x is minus 6x cubed. X squared times 9 is 9x squared. And then I'm going to distribute my 2. So plus 2x squared minus 12x plus 18. We're not done though, because we're going to clean it up. What do we have? X to the 4th. Oh, there's not much cleanup here, is there? minus 6x cubed. The cleanup you do have is plus 11x squared minus 12x plus 18. I'm not looking at my answer key, so if I made any mistakes, of course, tell me. And what is that right there? That's my standard form, isn't it? Took a little bit of work, but there is your standard form. Zeros. What about zeros?
The factors equal to 0.
Yeah, set each factor equal to 0. Here's a perfect thing of, this is why I don't want to set my standard form equal to 0. I don't want to have to undo what I just did. Okay, that would be annoying. So go back and use your factors. So x minus 3 equals 0. X minus 3 equals 0. X minus square root of 2 times I equals 0. And x plus square root of 2 times I equals 0. Okay? What do you get for your zeros?
Equals 3.
Or you get a 3. What else?
Square root of 2i.
Square root of 2i and a
Negative square root of 2i.
negative square root of 2. And let me point out, you guys do realize that I is outside, yes? Okay. I don't know why I didn't put the I in front and say I square root of 2. I probably should have. Not sure why I didn't at that point. Okay. Now, is it okay that I didn't state 3 a second time? It is. Okay. You don't need to state, unless they specifically say, you don't need to state a repeated 0. So I just said 3, then there's a positive square root of 2 times I, and then negative square root of 2 times I. Okay? Now, what about x-intercepts? Okay, do we actually have an x-intercept this time? Yeah, we had a real 0. The real 0 of 3 is going to be an x-intercept. What about the square root of 2 times I? No, my imaginary zeros aren't going to be x-intercepts. So we have one x-intercept this time at x equals 3. So anytime you have a real 0, that is an x-intercept. Okay? And if you would have graphed our standard form, you would see just that. You would see the x-intercept at 3. Okay, questions there? Okay. Get your brains on. We've got work to do. Example 2. With example 2 and 3, we're going to spend some time writing these functions. They ask us to write the polynomial function of minimum degree in standard form with real coefficients whose zeros include -3, 4, and 2 minus I. Okay, guys.
You do like x plus 3 times x minus 4, that x minus 2 plus I.
It would be. I'm going to write it slightly different to begin with. Okay, guys, work with me here. So I'm going to start off as f of x equals. Remember, to write a 0, it's x minus, or to write a factor, it's x minus the 0. So x minus -3 does become the factor x plus 3. X minus 4 becomes x minus 4. Now, for the moment, just to make sure everyone's on board, I'm going to write this as x minus the quantity 2 minus I. That's not exactly what Jack said, which is fine. He kind of did the next step. I'm not saying you need this step right here. where it's x minus that quantity, but that's what officially what you're doing. You're doing x minus that 0. Now, if you remove those extra parentheses, what does this indeed become? X minus 2 plus I, which that's what Jack said, right? And you feel free to go ahead and jump to that step. I'm not against it at all. I have to do my teacher job and make sure everyone sees how to get to that step. Now, we can't start multiplying yet. We're missing something. Well, you could start multiplying, but we're still missing something. Go back and read up top the complex conjugate zeros theorem. What does the complex conjugate zeros theorem tell me? If A plus BI is a 0, then so is its conjugate, A minus BI. How does this affect me? If 2 minus I is a 0, then so is its conjugate. What is the conjugate of 2 minus I? 2 plus I. So we also have to include the conjugate of 2 plus I. So in other words, we just went from 3 zeros to 4 zeros. So this is going to be x minus the quantity 2 plus I. Or if you prefer, go ahead and jump in and say x minus 2 minus I. I'm going to bring down my x minus 4 and my x plus 3. Okay, guys, those are the 4 zeros you need. This is going to end up being degree 4. They don't tell us that because they want you to remember that complex conjugate zeros theorem as you go to multiply. There's a lot of variations of what we could, how the order we could multiply. But here's the one thing I'm going to suggest. Anytime you have conjugates, don't multiply those with anything else until you multiply them with each other. You have to do the conjugates with each other. Okay? Because when we multiply the conjugates, all my i's are going to disappear. So, while we're at it, could we go ahead and multiply those first two? I definitely would. So, let's do math. X plus 3 times x minus 4. If I FOIL, x squared minus 4x plus 3x minus 12. We can go ahead and clean that up if you want. By the way, I hope you guys realize there's a lot to write in here, yes? Are you keeping your writing smallish? Sorry, I should have warned you sooner. Okay, if I clean this up real quick, this is what? X squared minus x minus 12, yes? Okay. On my imaginaries, we're multiplying 3 by 3. We're going to get 9 terms out of this, folks. So, I'm going to start by taking my x in the first parenthesis, multiply by everything in the second parenthesis. X squared minus 2x. I usually say minus ix. Then I'm going to distribute my negative 2. Negative 2x plus 4 plus 2i. Then I'm going to distribute my I. Plus ix minus 2i minus I squared. If we do this correctly, all of our i's will be gone after multiplying a set of conjugates. Are you seeing it? Minus ix cancels with plus ix. plus 2i cancels with minus 2i. So your I terms and your IX terms always just cancel each other out if done correctly. And then, what do you note about minus I squared? It's minus negative 1, which is, that's going to be a plus 1 in my next step, isn't it? Are all my i's gone? They are. So let's clean this up. There's just a single x squared term. Like terms, negative 2x and negative 2x is negative 4x, and then 4 plus 1 is plus 5. And one more time, multiply away. I'm going to start with x squared in the first parenthesis times everything in the next parenthesis. So x to the fourth minus 4x cubed plus 5x squared. I'm going to distribute my negative x. Negative x cubed plus 4x squared minus 5x. And I'm distributing my minus 12. Minus 12x squared plus 48x minus 60. Okay. Let's see if we meet in the end. There's x to the fourth. There's usually 2x cubed terms here. So minus 5x cubed. There's usually 3x squared terms. So 5 plus 4 minus 12 minus 3x squared. There's 2x terms. Minus 5x plus 48x, so plus 43x minus 60. Okay. If you ventured your multiplication on your own, did your end meet my end? Does mine match my answer key? It does. Okay, guys. Yes, we have some big problems in this lesson, okay? It's multiplying. Okay? It's watching out for all those little details and pieces, right? Okay. My goal is to finish with example 3 today. Is it going to take us 10 minutes? I guess it could, couldn't it? Okay. Example 3. Same directions. Write a polynomial of minimum degree in standard form with real coefficients whose zeros include x equals 1, x equals 1 plus 2i, and x equals 1 minus I. Okay, what do we need to know?
Well, if x minus 1, then we got the conjugates of the bottom.
Yeah. We're going to use the x equals 1. When we go to use 1 plus 2i, what else do we need to use? Yeah, we need to use the conjugate of 1 minus 2i. And I'll put it in my parentheses here in a moment. And then what else do we need to know? When we use 1 minus I, we need to use 1 plus I. Now, as you set these up for our sanity, it is important that put the conjugates next to each other, right? Putting the conjugates next to each other is going to cancel your i's out the quickest. Otherwise, you're making more work for yourself if you're not putting the conjugates with each other. Okay, let's write out what we have here. So, x equals 1 is going to be the factor x minus 1. I'm still going to do the parentheses within parentheses. Feel free to skip them. Then I'm doing x minus the parentheses of 1 plus 2i. What does that actually become? If you distribute that, it's x minus 1 minus 2i. Okay. Let's do the conjugate. X minus, in parentheses, the conjugate 1 minus 2i. Or that becomes x minus 1 plus 2i. And x minus the 0, 1 minus I, or it's x minus 1 plus I. And the conjugate of 1 minus I, so x minus, in parentheses, 1 plus I, or x minus 1 minus I. Okay, guys. For me, for what should be all of us, that x minus 1 is just going to hang out for right now. I'm going to keep carrying it down every step of the way because otherwise I'm afraid I'll forget about it. But I'm going to work with my conjugates here. By the way, you guys do realize, don't write too big. You're using all of this room, right? Okay. So, okay, when I multiply these 3 by 3s, they're each going to get 9 terms. So I'm going to start by distributing the x. X times x, x squared, minus 1x, plus 2ix. Then I'm going to distribute my negative 1. Minus 1x, plus 1, minus 2i. Then I'm going to distribute my negative 2i. Minus 2ix, plus 2i, minus 4i squared. Did I mess that up? Sorry, I feel like I messed up. No, okay. I think I'm okay. Sorry, guys. Now, I'm going to go ahead and multiply the other one, then I'll come back for cleanups. So I'm going to distribute the x. X squared minus 1x minus ix. I'm going to distribute the negative 1. Minus 1x plus 1 plus I. I'm going to distribute the I. Plus ix minus I minus I squared. Okay. My x minus 1 cancels down, or carries down. Did we get, okay, and my 1 with the 2 i's, did everything work out? 2ix cancels with minus 2ix. Minus 2i cancels with plus 2i. What's a minus 4i squared going to become? A plus 4. So if I clean up this parenthesis here, I have x squared minus x, and minus x is minus 2x, plus 1 and plus 4 is plus 5. Are you agreeing with me? Or are you even with me?
I can't see the other
Oh, I'm not sure where you're at, so. Okay. In my next one, I'm going to cancel what? Minus ix cancels with plus ix. Plus I cancels with minus I. So, x squared minus x and minus x is minus 2x. Plus 1, and what do we know about minus I squared? Minus I squared is going to become a minus negative 1 or a plus 1. Okay. Now what? Multiply something else, right? It's your pick. Me personally, I've been doing the x squared by x squared, and I save my x minus 1 for last. It makes my last step easy. Okay? I'm not saying you have to do that. With the conjugates, yes, you need to do that. Here, it doesn't really matter. So I'm going to keep my x minus 1, and I'm going to start multiplying these other two. Okay. X squared times x squared. X to the fourth. Minus 2x cubed plus 2x squared. Then I'm distributing my negative 2x. Minus 2x cubed plus 4x squared minus 4x. Then I'm distributing my 5 plus 5x squared minus 10x plus 10. Carrying down my x minus 1. What do we have? X to the fourth minus 2x cubed and minus 2x cubed. I see minus 4x cubed. 2x squared plus 4x squared plus 5x squared. 11x squared maybe. Negative 4x and negative 10x is minus 14x plus 10. And then I'm going to distribute my x and distribute my negative 1. X to the fifth minus 4x to the fourth plus 11x to the third minus 14x squared plus 10x. So each of my powers went up 1. Now I'm going to multiply by negatives, so minus x to the fourth plus 4x cubed minus 11x squared plus 14x minus 10. And I'm going to finish writing this up real quick. X to the fifth minus 5x to the fourth. 11. Is it 15x cubed? Minus 14 minus 25x squared. Is it plus 24x? Plus 24x minus 10. Did anyone find any mistakes on me? Okay, guys. Either tomorrow or Monday we'll go and look at the back side of notes, okay? You can start looking at some of the homework. 209, 2 through 36 evens. Won't be due till Tuesday at the soonest. Probably should be due Tuesday, I would think.